forgot to record again. Okay, so make sure you have the same index, make sure you have the same radicand. We're gonna add and subtract these binomial radical expressions. So if you look at letter A there, my guess is you can probably figure out what this is without me telling you a thing. What do you think 5 rad 3 plus 2 rad 3 is? 7 rad 3, okay? Think of it kind of like your radical is your variable. It's not a variable, but we kind of treat it the same way we treat variables. If there's 5 apples and we add 2 apples to it, it's 7 apples, right? It's not 7 oranges now, it's still 7 apples. So 5 rad 3 plus 2 rad 3 is 7 rad 3. Get my pen back. Okay, 7 rad 3. So how about the one right below that? 7 4th root of 5 minus 3 times the 4th root of 5 is 4 4th root 5. Okay, so we're just subtracting what looks more like a coefficient to the radical. But you have to make sure this is a 4 and a 4, and this is a 5 and a 5 in order to be able to do that. Okay. Letter C over here. 2 rad xy plus 12 rad xy. What do you get? 14 rad xy. Okay. How about letter D? 2 times the cube root of x plus 5 times the square root of x. Feels like a trick question, right? No solution. You can't do it. It's not technically no solution because we're not solving an equation, but you can't combine any of that. So your simplified expression is just how you see it. 2 times the cube root of x plus 5 times the square root of x. That's as simple as you can go with it. So you don't say no solution. We're not trying to solve anything, right? We're just simplifying an expression. It is as simplified as it can be. So really you could just put a box around the original thing, okay? Okay. Sometimes it's not as straightforward as that, where you're gonna have to actually simplify before you combine. Do you see what I mean here with this one? What do we have to do first? We need the same radical if we're gonna be able to combine anything. And right now it's like, well, you can't. It's 20 and 45. But you can simplify the square root of 20 and you can simplify the square root of 45. So that's what we're gonna do first. We're gonna break these down. Don't forget about the number out in front. What perfect square and non-perfect square for 20? 4 and 5. Okay, over here you have 3 and what perfect square? 9. And 5. Oh, look how convenient, a 5 and a 5. So this would be 5 times 2, or 10 rad 5. This would be 3 times 3 times rad 5, so 9 rad 5. And then we can combine now because we have the same index and the same radicand, right? They're both square roots, they're both 5s under the radical. So you would get what? 19 rad 5. Okay. Questions on that? Okay, I'm gonna have you try this one. So you're gonna simplify the rad 18, simplify the rad 8, simplify the rad 72. Don't forget about your numbers out in front. And see what you get. Feel free to talk to a neighbor if you're having trouble coming up with the number.
answer or and 2a?
How did I get the answer?
Like, why did you do 5 times 2?
5 times 2. Right here?
Yeah.
So this is the square root of 4, and the square root of 4 is 2. So right now it's 5 times the square root of 4 times the square root of 5. So I'm going 5 times 2 times the square root of 5. So that's 10 times the square root of 5.
Okay.
That makes sense?
Yeah.
Yeah, you're multiplying those things together, and then adding, once you've found the product, then you'll add them together. Does anyone have an answer?
8 rad 2.
Say it again.
8 rad 2.
8 rad 2. Anyone get 8 rad 2? You should. Hopefully. Here it is. So 18 is going to break down to 9 and 2. 8 is going to break down to 4 and 2. Remember, we want our perfect square on the left because that's just going to keep all of our whole numbers together. 72 breaks down to what? Because you have options here, but there's one best option. What is it? 36. Yep. You could start with 4, but then you have more work to do. I don't recommend it. Always shoot for the highest one, okay? So this is going to be 6 times 3, or 18 times rad 2. This is going to be 4 times 2, or 8 rad 2. Notice we're subtracting here. And then this is going to be 3 times 6, or 18 times rad 2. So when we combine, 18 rad 2 plus 8 rad 2 is 26 rad 2, but take away the 18 rad 2 again, and you're left with 8 rad 2. It's good, right? Totally doable. Okay. This is our last problem. Short lesson. We're at 7 minutes right now, and 2 of those were just me giving you time to work on a problem. When we add variables, again, you guys have done work with variables, so this should feel very familiar. But now we're just going to be adding things together or subtracting things. Here it is. We need to break these down because they're not the same radicals right now. So out in front of this is a 2, and then we're going to do our 2 different cube roots, and then a 5 with our 2 cube roots here. Okay, cube roots, not square roots, right? So we don't want to use 16. 16 is a perfect square. It's not a perfect cube. What are we going to use for our perfect cube with 16? 8. 8's the perfect cube we want. So 8 times 2. And then x to what power on the perfect side? Bless you. The third power. Yep. So there's not going to be any x's on the right with the 2 there. 54. What perfect cube is 54 divisible by? Remember, it goes 8 and then 27, right? 27 times 2. Here's a little trick. If you're not sure what it is, but you found this one okay, divide by that number and you'll probably find the perfect cube, right? 50, because we want these 2 numbers to be the same. So if I know that should be a 2 to make this simpler, divide by 2, you get 27. And the x to the third is going to go with that one too. So this is going to be 2. What does this equal? The cube root of 8x cubed. 2x, right? The cube root of 8 is 2. Cube root of x cubed is x. And we still have the cube root of 2 behind it. Plus 5 times, what is this going to equal? 3x, right? 3 times x times the cube root of 2. Okay, so keep going. This is 4x cube root 2 plus 15x cube root 2. Add those together. 4x plus 15x is 19x times the cube root of 2. Questions on that? Yeah, Jada. When after this point? Okay, so if like, do you understand how I got those numbers, that first row? Or how to get those numbers is what you're stuck on. Okay. I'm just going to erase the whole thing and show you again. I'm done. That's the whole lesson for today. So you guys can get started on your homework, and I will re-explain this one for anyone that wants to see it again. Yeah. Oh.
Can you go back to D, the one before?
Just what the answer is?
Yeah.
It's 8 rad 2. Okay. So if you want to see this one again, here's what we're doing. You need to take this and break it into a perfect cube and a not perfect cube, right? We still have the 2 out in front. So if you think through your perfect cubes, it's 8 and then 27 and then, is it 81? Yeah. So you think through those numbers, right? Is this 16 divisible by any of those? Well, 8 is divisible, 16 is divisible by 8. So I would go 8 times 2 gets me 16. And then I need to figure out of my x to the third, can I divide that number by 3 or do I need to pull some of the x's out? Well, 3 is divisible by 3. So I'm going to put all of them on the perfect side like that. So far, so good? Okay. Then from there, we still have this 5 out in front. And then we're going to break this into a perfect and a not perfect. Okay? So we need to look at the number, 54, and think, is 54 divisible by 8? Is it divisible by 27? Is it divisible by 81? Which one works? So you can just use your calculator for that. 54 divided by 27, and you'll get 2 on that. So 27 is the perfect cube. 2 is the one that is not a perfect cube. And then you have x to the third. So we have to figure out if I'm going to be able to divide by 3, how many of those are going to go on the perfect side. 3 divided by 3 works. So I'm going to put them all there. X to the third. Okay. Then we keep going. So simplify what can be simplified. So take your perfects. This one's perfect, right? 2 times the cube root of 8, so this portion of it is 2. So it's 2 times 2. The cube root of x to the third, right? So I'm talking about this right now. I cube rooted it. You can plug it into your calculator when you cube root it, right? Math 4 and then 8 is saying 2 times 2 times 2 gets you 8. But yeah, just plug that into your calculator if you don't know it off the top of your head. That's totally fine. So the cube root of x cubed is just x, okay? And then we still have this that we can't do anything with. So now this becomes 4 times x times the cube root of 2. So that is this simplified. So we have 4x cube root 2 plus, and now we have to figure out what this is simplified. So from there, we're going to break down this cube root of 27x cubed. So again, you can plug into your calculator, math 4 is the cube root, and then 27. So it'll show up on your calculator looking like this, and it will tell you that's 3. So you're going to say 5 times 3, and then take the cube root of x cubed is just x. And then you have your cube root of 2 from there. So simplify that. 5 times 3 is 15 times x times the cube root of 2. So this just became this. Okay? So now this is what we have, and we're adding it together. So it's going to be 4x cube root 2 plus 15x times the cube root of 2. And now you have the same radical. So now you can add the coefficients to that. So 4x plus 5x is 19x times the cube root of 2. Okay? You what? picture? Yeah.